So we are starting with the unit 2, that is AC circuit, as your exams are near. So from lecture 14, single phase AC circuit analysis, I'm starting this one part. Okay, lecture 14 to lecture 19, I think it to lecture 19 it will come in your syllabus paper. So starting with the basic AC circuit. Okay, so basically in the AC circuit we'll have three types of load. One is the load is resistor. Okay, another load is the inductor, and another load is the capacitor. I hope you all of you know that what is resistor, what is inductor, and what is capacitor, right? Basically, inductor is a device which opposes the change in flow of current. Okay, so it opposes the change. It doesn't like the change, it opposes the change. Let me give you one example, because if you know the basic, then only you will be able to do the difficult question. Suppose this is an inductor, and as you know, inductor is denoted by L. Usme I'll provide the current 5 ampere from the very long time. Then there is a no issue. 5 ampere ka 5 ampere we will get it in the output. But what will happen if you suddenly change the current from 5 ampere to 15 ampere? So there is a change in current. So change in current it won't allow. So output में you will not get suddenly 15 ampere. 5 से वो पहले धीरे धीरे 8 होगा, then it will become 10, then 12, then 15. Okay, so basically inductor main definition which we are going to use in BT, that is it opposes the change in flow of current, and as you know its unit is Henry, and Henry is denoted by H. Similarly, we'll have capacitor which stores electrical energy, right? And capacitor unit is farad. Okay, so these are the basic thing of AC circuit. पूरा AC circuit तुम्हारे इसी के आसपास है about resistor, inductor and capacitor. Okay, now one more question that I want to ask, that if you are having a resistor wire and if you are having a plain wire, can you tell me that in which case current can flow easily? So similarly, I'm asking you the another question, that if you are having an inductor or the plain wire, then in which case current can flow easily? In the inductive wire or in the plain wire? Tell me. Current can flow easily, obviously again in the plain wire only. That means there is some amount of resistance present in the inductor. Resistance, what resistance ka kya kaam hai? That it opposes something, right? If suppose 5 ampere of current is flowing and 5 ampere of current is flowing from here, that easily current will go through the plain wire. That means there is some amount of resistance present in the inductor, and that resistance is technically known as inductive reactance, which you are going to use in the numericals, and inductive reactance is denoted by the term XL. Okay, inductive reactance is denoted by XL. I'm writing that define also. It is basically the kind of resistance only that is offered by inductor. ठीक है कि resistor inductor के अंदर there is some amount of resistance. It's not like कि हमने कोई extra resistor add कर दिया. It's a inbuilt resistance present in the inductor, and that is denoted by XL, and formula for XL is equals to omega L that you are going to use. And what is omega? Basically omega is the angular frequency, and if you know about the formula of omega equals to 2 pi f. Okay, so if I'll substitute the value of omega over here, then it would be 2 pi f L. So what is the complete formula which you are going to use in the numerical? That is 2 pi FL. And can anyone tell ki what should be the unit of inductive reactance according to you? So similarly, I'm asking you one again same question. If you are having a plain wire or the wire with the capacitor, in which case current can flow easily? The plain wire or the capacitive wire? According to you, tell me. In which case current can flow easily? The plain wire or the capacitive wire? Plain only, correct? So again, that means there is some amount of resistance present in the capacitor. Again, we didn't add any amount of resistance, but there is inbuilt resistance present in the capacitor, and that resistance is technically known as capacitive reactance. Okay, and capacitive reactance is denoted by Xc, and what is the formula for the Xc? Xc is equals to 1 over omega c. Again, omega is the angular frequency, so Xc is equals to 1 by 2 pi Fc. So again, if I'll write down the define of capacitive reactance, it's again the kind of resistance offered by capacitor. So these are the formulas which are not given in your handbook. I'll say that you must learn these formulas. Okay. Again, I'm writing, if you are having a resistor, then their resistance is resistors only. If you are having inductor, then inductor resistance is XL, and XL formula is omega L, and omega L is 2 pi FL. But if you are having capacitor, then capacitor resistance is Xc, and Xc is equals to 1 over omega c, that is 1 by 2 pi Fc. Then we'll have RL. Okay, maybe there will be the combination of different load na. It can be R and L, it can be R and C, right? And it can be the combination of R, L and C. अब तुम्हारे पास what you will think कि मैम is there any combination of L and C? तो no, there is no combination of L and C, क्योंकि वो oscillation बन जाएगा, and मतलब इंडक्टर की एनर्जी कैपेसिटर में जाएगी, कैपेसिटर की एनर्जी इंडक्टर में जाएगी. So you will not get any single question based on the combination of inductor and capacitor. Okay, so only we'll have the combination of RL, RC and RLC. So what about their resistance? इनके resistance को हम क्या बोलते हैं? If anyone knows about it, tell me, because you must have studied this thing in your 12th class as well. Impedance, that is correct. So their resistance is technically known as impedance. Impedance is denoted by Z. Okay, so Z formula is, if there is RL, so Z formula is root of R square plus XL square. But if it's RC, then Z formula is root of R square plus XC ka square. But if there is a combination of RLC, then the complete formula is root of R square. Then XL and XC both will be included. Then it would be XL minus XC ka whole square. ठीक है? So these are the basic formulas which you are going to use in the numerical. Sometime you need to learn these formulas in the complex form also. ठीक है? Complex form means J form. Like in maths, remember कि complex में हम क्या पढ़ते थे? I means iota पढ़ते थे. Same iota will be denoted by, over here is J. Maths में will denoted by iota. In science, in BT will denoted by J. So if it is the combination of R and L, then impedance formula we can write it down as R plus JXL. If it is the combination of R and C, then impedance formula is denoted by R minus JXC, because RC होता तो minus होता है, RL होता तो plus JXL होता है, and if it is the combination of RLC, then Z is equals to R plus J of XL minus XC. ये फॉर्मूला यूज नहीं होएगा, तो इट्स बेटर टू कंफ्यूजन. मैं मतलब कंफ्यूज बहुत कम करूंगी, कम फॉर्मूलेस बताऊंगी. फ्रॉम मेनली 3-4 फॉर्मूलेस से तुम्हारा कंप्लीट हो जाएगा. ओके, सो राइट डाउन ऑल दीज फॉर्मूलेस व्हिच आई टोल्ड यू. So you are going to learn today the conversion. What are the conversion? Like we'll have basically two form. One of the form is rectangular, that is denoted by rec. Another form is the polar, that is denoted by pole. Okay, so that you are going to definitely use. इस type का question you will definitely get in midterm as well as in end term. 100% guarantee कि इस form को use करके you will get one question definitely from midterm, maybe one or two question from end term. Okay, so for that your base should be clear. So rectangular form is basically the J form, as I just told you कि J is similar to iota, which you have studied in the maths, and polar form is related to the angle form. Suppose you are having the combination of R and L. Suppose you are having 2J5. ओके, J5 इज बेसिकली एक्सेल, तो जहां भी J आ जाएगा दैट मीन्स इट्स एक्सेल और XC. तो हाउ वी कैन डिनोट इट बाय दिस टर्म, कि अगर ऐसे आएगा तो हाउ वी कैन डिनोट इट, एज यू नो इट्स द कॉम्बिनेशन ऑफ R and L, एंड आई टोल्ड यू कि इफ देयर इज अ इंडक्टर देन इट वुड बी पॉजिटिव, सो वी कैन राइट इट डाउन लाइक 2 plus J5, right? Z is equals to 2 plus J5. Then similarly we have another term Z2. Suppose we'll have 4 plus J6. Now I'm saying that you need to add these two impedances. Okay, suppose we are adding these two impedances, Z1 plus Z2. So how we are going to add these two impedances? This is the real term, okay, and that J term is known as the imaginary term. ओके, वाई जे टर्म, अगर मैं और डीप में जाऊंगी तो वाई जे टर्म इज नोन एज इमेजिनरी टर्म, बिकॉज जे टर्म डिनोट्स वेदर इट्स अ इंडक्टर और कैपेसिटर. वाई इंडक्टर एंड कैपेसिटर टर्म्स आर इमेजिनरी टर्म्स? बिकॉज इंडक्टर एंड कैपेसिटर डज नॉट कंज्यूम पावर. ठीक है, कौन सी पावर, कैसी पावर, व्हेन विल गो टू द पावर टॉपिक तो उसमें डिटेल में बताऊंगी कि इंडक्टर और कैपेसिटर पावर को कंज्यूम नहीं करते, विच पावर दे डिडंट कंज्यूम, व्हाई इट इज नॉट कंज्यूमिंग, एवरीथिंग आई टेल यू इन डिटेल व्हेन आई टेल यू द पावर वाला टॉपिक इन द एसी सर्किट ओनली. अभी के लिए जस्ट यू नीड टू रिमेंबर कि जे वाली टर्म इज द इमेजिनरी टर्म. Okay, why? Because it is associated with the inductor and capacitor. Understood up to here? कि normal term is the real term and imaginary term is the J wali term. So how will we add these together? Real term is added with the real term and imaginary term is added with the imaginary term. So how it would be? 2 plus 4 is 6 plus J as it is 5 plus 6 is 11. So that is the answer of Z1 plus Z2. Got it? How we can add it? Z1 plus Z2. Now the same thing I am doing, I am asking to do you by yourself, that is Z1 minus Z2. If I want to subtract these two impedances, tell me what would be the answer. So if I'll subtract these two impedances, so 2 minus 4 is minus 2, J5 minus J6 is minus 1. Okay, but the thing is that in the rectangular term what we can do, we can either only add or subtract. Okay, if the term is in the rectangular form we can add or subtract, but if we want to multiply these two, if we'll say कि मैम Z1 multiplied by Z2 करो और Z1 divided by Z2 करो, for that the term should be in the polar form. So in the polar form we can do multiplication and division, and in the rectangular form we can do addition and subtraction. Okay, now back. Now after that we'll move towards the polar form. As I told you, polar form is the angle form. Suppose we'll have Z1 is equals to 4 angle 30 degree and Z2 is equals to 2 angle 60 degree. Now I am saying that you need to add these two terms, sorry, multiply these two terms together, Z1 into Z2. So what we'll do, again real term is multiplied with the real term, that is 4 2 ja 8, and angle is added if in case of multiplication, means 30 plus 60, then it would be how much? That is 8 angle 90 degree. Okay, again if we want to divide, Z1 divided by Z2 is how much? 4 divided by 2, real term is divided with the real term, 4 divided by 2 is 2 only, and angle would be subtracted. तो angle कितना हो जाएगा? 60 वाला ऊपर जाएगा, so that would be 30 minus 60, so angle would be 2 angle minus 30 degree. तुम्हें फील हो रहा होगा like ma'am is telling so basic, but if you know the basic, then slowly and slowly I'll move to the upper level and then I'll teach you the question which already comes in your paper, तो तुम उसे आसानी से कर पाओगे क्वेश्चन पेपर वाले क्वेश्चन को. ओके, सो इन दिस स्लाइड आई टोल्ड यू कि रेक्टेंगुलर फॉर्म में इज डिनोटेड बाय जे, पोलर फॉर्म इज डिनोटेड बाय एंगल. In rectangular form we can do only addition and subtraction. In polar form we can do only multiplication and division. Real term is added with the real term is added subtracted with the real term, and similarly हम इसमें कॉम्प्लेक्स के थ्रू उल्टा भी कर सकते हैं, लाइक रेक्टेंगुलर में हम मल्टीप्लिकेशन और डिवीजन भी कर सकते हैं. दैट ऑल्सो आई टेल यू, बट स्टेप बाय स्टेप. ठीक है, अभी के लिए माइंड में यही डालना है दैट इन रेक्टेंगुलर फॉर्म वी कैन डू एडिशन एंड सब्ट्रैक्शन, इन पोलर फॉर्म we can do multiplication and division. Now the question arises कि ma'am what will happen if we'll have two terms, 2 plus j3 suppose, and z2 is equals to 4 minus j6 suppose, and your teacher told you to multiply it, that is z1 into z2. So for that I'll tell you that you need to convert it into the polar form. And ma'am, how we can convert it into the polar form? So for that you must use your calculator. सबसे पहले for that suppose I'm telling you, take out your calculator. Okay, I'm telling you the conversion of rectangular form to polar form. Rectangular form means J, right? So I'm telling you according to FX 991 ES. तो सबसे पहले on press करो, then after that there is a button over here, shift, then press shift. Okay, then there is a button over here of plus, they have written pole, and there is a button over here negative, rec over here. Rec means rectangular, pole means polar. Now see, suppose we want to shift, we want to convert 2 plus j3, it's in the rectangular form, and we need to convert it into polar form. So press first on, then shift, and we want to convert it into polar form, then press plus button. Okay, then in your calculator you will see there is a term called, क्या आ जाएगी, pole. आ गई? What you will do, 2, 3 and the bracket close. देखो 2 तो you can directly write down, and comma button कुछ cases में directly होगा, but in some calculator you will have this curly bracket. Okay, and in this curly bracket yellow color में they have write it like small comma, right? तो जितने भी तुम्हारी ये येलो कलर वाले टर्म्स हैं, they'll get it by getting shift. So how will you get this comma button? Shift press करोगे, bracket press करोगे, then you will get comma, then 3, then bracket close, and then equals 2. So now you got to know that how to convert this rectangular form to polar form, right? So 2 plus j3 you are getting as 3.6, angle is 56.3. Similarly, please convert it by your own. If it is minus and you need to convert it into which form, तुम्हें pole में convert करना है तो you need to write down pole. Okay, 4 minus है तो 4 comma minus 6. Do it and then tell me the final answer. So you are getting z2 as this value. Now if I'll say z1 into z2, you can do it. If I'll say z1 divided by z2, that is also you can do it. ठीक है, कर सकते हो ना? Now the thing is कि ma'am, how can we convert? Now you told me कि convert rectangular to polar, but what if we want convert polar to rectangular? Okay, so as I told you, like this is the polar form, and if we want to convert back into the rectangular form, तो आंसर यही आना चाहिए, right? आना चाहिए ना? So for that what we'll do, again take out your calculator, press on, press shift. Now we want to convert it into rectangular form, right? So if you want to convert it into rectangular form, then in that case you need to write down rec. So rec 3.6 comma 56.3 bracket 30 close. तो ये करके देखो, your answer must be like this. Exactly ये नहीं आएगा, you will get 1.99 and 2.99 something. So you'll get, अगर ये आ रहा है then that means your calculator is fine. अगर ये नहीं आ रहा then that means there is some error in your calculator. Okay, this is the best way of checking out the calculator because calculator में problem हो जाती है. Do it and check it, right? So why there is a need of conversion to rectangular to polar or polar to rectangular, and how we convert it from polar to rectangular and rectangular to polar. So I'll tell you the main method, ठीक है? I'll tell you that method also कि अगर तुम्हारे पास डायरेक्ट रेक्टेंगुलर है तुम डायरेक्ट भी मल्टीप्लाई कर सकते हो, बट लेटर ऑन, स्टेप बाय स्टेप, ठीक है? Now I am telling you why and where to use these kinds of conversion and how you are going to use this conversion. Okay, like suppose they'll provide you the numerical. Again, obviously they don't ask you directly conversion, they'll give you the numerical like this. Again, I'm telling you from the basic numerical. Suppose they said this is the 220 volt, okay, and angle is 0, and they said this one is z1 is 2 plus j4. Again I'm taking the random value, this is z2 is 4 minus j6. Okay, 2 plus j3 कर देते हैं, 2 plus j3. Now this is the current I1 and this is the current I2, this is I. Now they'll ask you to calculate I or I1 and I2. Okay, so this kind of numerical you will get it in exam. Itna basic nahi, higher level. Okay, now see, what if you want to calculate I? As you know, I is the total current, so can we say that I1 plus I2? Yes or no? So we have two method. We can get direct current also. How? Total current must be equals to the total voltage divided by the total impedance, right? So total voltage is how much? 220 angle 0, but total impedance, see, impedance is denoted by Z and total impedance we can denote it by ZT. So this is a standard way of representation. तुम represent कुछ भी कर सकते हो, like you can represent Z and everything, but the standard way of representation is ZT. ठीक है, ZT means total impedance. And as you can see that Z1 and Z2, they are connected in series or in parallel? Tell me. Are they connected in series or in parallel? Parallel. So for that we need to calculate ZT. So as you know, Z1 is parallel with Z2, so that would be Z1 into Z2 divided by Z1 plus Z2. Correct? यही होगा. So Z1 into Z2 means 2 plus J3 multiplied by 4 minus J6 divided by 2 plus J3 then plus 4 minus J6. यही होगा. So in the denominator, as you can see, we'll have 2 plus J3 and 4 minus J6. It's in the rectangular form, so you can do it directly. क्या आ जाएगा बताओ मुझे, tell me. But you will get it in the denominator. Real term is added with the real term, 6. Imaginary term is added with the imaginary term, so it would be 6 minus J3. ठीक है? Now, but as you can see in the numerator, we have to multiply. For the multiplication, we need to convert it into the polar form. That's why I told you how to convert it into the polar form. So you'll get something into the polar form that you have already calculated. Again you multiply it. Okay, अब further हमें what we need to do, division के लिए हमें जो denominator है that also we need to convert it into the polar form. Then we'll get the final answer in the polar form. Now one more question student पूछते हैं कि मैम final answer must be left in polar form or in rectangular form. So I'll say कि अगर टाइम है तो दोनों फॉर्म निकाल दो, अगर टाइम नहीं है तो whatever you will get it, whichever form you will get it, that is also correct. So टीचर तुम्हें गलत नहीं करेगा कि रेक्टेंगुलर में क्यों निकाला, पोलर में क्यों नहीं निकाला, both are correct. Okay, ideally it should be in polar form, अगर आइडियल की बात करो तो. Okay, So see, this is one of the method that we can get I. Another method is we can separately calculate I1, that is V by Z1, or we can get I2, that is V by Z2, then we can add it. Okay? Now the question arises कि whenever you will use the parallel circuit, it's better to use current division rule, and when you need to use current division rule, when you will get this kind of circuit, as I just told you, this is the question, exact question you are getting in 2024 paper, that is for end term paper. I'm taking the same values. This is the question. See in the group also, I send it to you. This is 2024 BT end term paper. Z1 they have mentioned, that is 10 ohm. Z2 they have mentioned, that is 20 ohm. Z3 they have mentioned, that is 5 plus J 15 ohm, right? They said find the value of the supply voltage Vs, and this one they have given that this one voltage is the 100 volt. So see कि basic से उठ के this kind of numerical you will get it कि you have to use your mind little bit कि how we can get voltage. Okay, they have provided you this voltage. So for that, as you know, पहले खुद सोचो. Before solving this question, I'll tell you the current division rule. That is the part of the DC circuit. थोड़ा सा brush up हो जाएगा. See, current division rule is shortly known as CDR. Okay, it is known as CDR. Another thing is कि it is applicable only and only in parallel circuit. If there is a series circuit, then we can't apply this rule. Another thing, it is used to calculate current. Okay, so suppose if we'll have this kind of circuit, we'll have resistor in combination of two parallel resistor. ठीक है, suppose this is 4 ohm, this is 6 ohm, this is 8 ohm, and this is 10 volt. Suppose in this current I1 is flowing, and in this current I2 is flowing, and in this current I is flowing. So now I'll tell you the direct formula of calculation of I1. अगर वैसे निकालोगे तो then that will be a lengthy method कि first you need to calculate I, then so on and so on. But by CDR, by current division rule, you will have the direct formula of calculation of I1. What is the formula? The formula is the total current. Here the total current is I am writing down the total current multiplied by जिस branch में you need to calculate the current उसके opposite वाला resistance that is connected in parallel. Suppose you need to calculate I1, तो I1 की opposite resistance connected which is in parallel is 8 ohm. Okay, divided by the sum of resistor which are connected in parallel. So what are those two resistors which are connected in parallel? That is 6 plus 8. So total current you need to calculate in this case how? That is total voltage divided by total resistance. Total voltage is 10 volt. Total resistance is, as you know, 6 is connected in parallel with the 8. Then 4 is combined in series with the this combination. ये तो आता है ना series parallel basic terms. Then we can get I. Now similarly, according to this, you tell me what should be the value for I. Now as you can see that this kind of circuit and this kind of circuit is same, right? So we'll solve this question in the next class. तो इसमें मैं थोड़ा सा हिंट दे देती हूँ, ट्राई करना, नहीं आएगा तो I'll tell you. वोल्टेज गिवन है, रेजिस्टेंस गिवन है, then we'll get I2, right? अब I2 गिवन है by using the current division rule, as I told you, I2 is equals to I into इसके अपोजिट वाला इम्पिडेंस. I2 के अपोजिट इम्पिडेंस इज Z3 divided by Z2 plus Z3. So I2 value we have how much? That is V by R. So 100 by 20. So how much is I2? That is 5 ampere. So I2 value they have given, that is 5 ampere. I value is not known. Z3 is known. 5 plus J 15. Z2 भी पता है, Z3 भी पता है. तो can you get I? Yes or no? बताओ. पूरे टर्म में एक ही वेरिएबल अननोन है. See, in this class I told you about this AC circuit. If you need coaching, okay, for this particular BT, BE or maths or physics for any subject, then you can contact me on this number. Thank you.